The rest of the class, we will start a new topic called abstract data types. We'll see what an abstract data type is now. Okay. So what is an abstract data type? An ADT is similar to a function. A function, we want to look at it differently, generalizes the notion of an operator. Instead of using operators like plus, slash, which are defined, a function operates on data supplied, like the example, the recursive sum. The recursive sum and operates on data. And so it's like defining an operator on the data that is being supplied. So this is like a user defined operator. Okay. Now, what we could do is, so you notice that we had our own user defined. Let me take the selection sort. The operator was sorting, and the data was in an array. Okay. So now we can go one step further. An array was is a defined type in any language. Can go further, and you can also define user defined data types, and you have procedures that or functions that operate on them. We'll take an example in a little while. So one way of looking at it is we want to represent it pictorially. I have a mathematical model. And which you have some operations. Then this mathematical is a data model over here. And this is your abstract data type. And you have pseudo language programs which are equivalent to the operations that we defined. And finally, this boils down to a actual data structure and you have a higher level language program. Let me take a simple example. The idea of a set is an abstract data type. And as soon as you see a set, you have a set of unique or a collection of, a collection of unique elements and the operations that you perform are union, intersection, complement. Okay. So now the question is, all of you by now know what are the various data types that are available in a language like C. So now you're familiar with the array, and there's another data structure called linked list. And you could represent the data of the set of elements can be represented using either arrays or linked lists. But surely what is available, suppose you are the implementer of the set, okay? So you implement it using an array or a linked list or whatever. Then you may even represent, if you're just interested in or out, for example, present or not present, you may just have Boolean variable that represents the set. But for a person who's using your program, what you have available are the operations, union, intersection, and complement. The most important point about abstract data types is that just like functions encapsulate the functionality ADTs can be used to encapsulate data types. Okay. For example, another example of an ADT. Matrix. Now, I can define an ADT called matrix, and I have, let's say, M1, M2, RF type matrix. Then I should be able to write M3 equals, M3 is assigned the value of M1 plus M2. M3 equals M1 star, M2, and so on. So what we're saying is we can define the operations of addition, subtraction, and multiplication in the context of matrices 2. Okay. There are many basic ADTs. We will start with the simplest ADT. Many ADTs have array, list, stack, queue, binary tree, then binary search tree, graph, etc. Okay. We already saw set, matrix, and so on. So first, let us look at why is array an ADT. It has an implementation in the language, but let's define this array ADT and see what is different, the operations that you would like to have. First of all, how do we define an array? A collection of elements where each element can be indexed or can be accessed by an index. Okay, this is what we want. And the elements in an array are homogeneous. Generally, newer languages support even heterogeneous elements like Python and so on. What are the operations that we want to be performed? We'd like to do this. Set I, comma B, which means that set the element at index I to B. Another operation, get I get the element at index I. Okay. Then another operation that's nice to have, traversal of array Print all the elements. Now let's see how arrays are actually implemented. Simplest, as in C, only store the memory address of the first element. A stricter implementation also stores size to avoid overruns. Okay. How is an element accessed? Saying an element at index I simply C star S plus B. Some base address, index, and size of the element. So this is one type of an array. Languages like Python enable storage of heterogeneously sized elements. And so generally, an address to the item is stored rather than the item. The actual value at the particular location. Primary reason for this, addresses are fixed length. Items can be variable length. So if you compare accessing array elements in C versus Python, it will be, or Java, it will be much slower in Python. Okay? But today Python is very popular popular, it's easy for anybody to code. Okay. So I've just given you the, so in the next class, what we will look at, we'll look at extensively some, some operations on arrays, and in particular, we will look at searching and sorting algorithms. So get element I. So when you look at an array, for example, and I say A of I, A bracket index I is like an operator that operates on an array, which means an array. And when I say A of I is assigned the value of C, this is again an assignment operation which actually takes the base address of the array plus I, finds the memory location, and in that location stores the element C, and you know about this in your computer organization course. So we'll stop here for today, and tomorrow we will take some sorting, searching